Okay, so in this video, we're going to talk about eccentricity with ellipses. And so before we can discuss eccentricity, we just need to discuss like the general definition of conic sections. So a conic section, I showed you like the informal definition of like how we think of it as a plane intersecting with a cone. But the formal mathematical definition is that a conic section is the set of all points in a plane such that the ratio of the distance from a point P to a fixed point and the distance from P to a fixed line is constant. Okay, so this is like generalizing all of those geometric definitions of other conic sections that we've been talking about in this series. And so this idea of these like constant ratios, these ratios are called the eccentricity, and we denote that with E. So this means E as in eccentricity and not E as in like the natural number, naturally occurring number E. So just keep that in mind, like in the context of conic sections, E means eccentricity. It's pretty easy to calculate. So you have to know C divided by A for an ellipse. So you know how to get to C, that's your A squared minus B squared, and then your A is found directly in your ellipse equation. And we think of eccentricity as a measure of roundness for ellipses. So for ellipses, E falls between 0 and 1, okay? And just to kind of compare eccentricity, like eccentricity is different depending on what type of conic section you're talking about. So like if you're talking about parabolas, so if you remember the construction of a parabola, the distance between the focus and the directrix is always the same. So when we're talking about a conic section, so this would be like, you know, that fixed point and that fixed line. So in this case, since these distances are the same, that ratio would be equal to 1. So eccentricity for parabolas, like one of the defining characteristics of a parabola is that its eccentricity is always equal to 1. And that will matter more as we get a little farther along in this series. So I think it's pretty basic to calculate eccentricity in ellipses. So we're going to find the eccentricity. So you have to look at an equation like this. So you know that the larger of the two numbers in the denominator is always your A. So in this case, my A is going to be equal to 3 and my B is going to be equal to 4. So to calculate my C, I need to take A squared minus B squared. So I take the larger number minus the smaller number, and I get 5. So my C is going to be equal to the square root of 5. So if eccentricity then is just C divided by A, then I literally just take square root of 5 over 3. And so there is your eccentricity. So I think it's like a pretty straightforward thing. So with this other equation, so I've got x squared plus 25, y squared equals 25. So this has a little curveball in it. So what do you need to do first with this particular equation? Well, you need it to equal 1, so you need to divide everything by 25. So I can divide everything by 25. So then I'm left with x squared over 25 plus, I'm going to write this as y squared over 1 just so I don't forget the number. And so now I can see, so to calculate my c squared, I can take 25 minus 1 to get 24. And so now I can see from looking at this, my A is equal to 5. I really just need to know the C, right? The C is equal to the square root of 24. So my eccentricity will be the square root of 24 over 5, which if I wanted to simplify that square root, so this would be 4 times 6. So I can take the square root of 4. So this would be 2 times the square root of 6 over 5. So there's your eccentricity. Okay, so sorry, just leave that up there for a second in case you want to pause the video. Okay, so the other way that you could deal with eccentricity is if you have to write the equation of an ellipse. So find the equation of an ellipse with E equal to 3 over 4, with foci equal to negative 2, 0, and 2, 0. Okay, so one common issue with this is, so remember, eccentricity is C over A. So if I have eccentricity equal to 3 over 4, that does not automatically mean, that does not imply that my C must equal 3 and my A must equal 4. So that's like a really common pitfall with this. All we know is that this is the like how this ratio got simplified, right? So you don't want to automatically assume, oh, these must be the numbers. And if anything, so I've got my foci at negative 2, 0, and 2, 0. So that tells me a lot, right? So if my foci are here at negative 2, 0, and 2, 0. So let's see, I'm going to maybe mark 2 of these. So that tells me then that my center is at 0, 0. That also tells me about what the distance of C is. So remember, the distance from the center to a foci is your C. So my C is actually equal to 2. So, okay, so now knowing for a fact that my C is equal to 2, now I can play with this ratio. So if I've got my eccentricity equals 3 over 4, well, I know that that's going to be equal to C over A. And now I can go a step farther and say that I know that my C is equal to 2, and now I have enough information that I can solve for A. So I get 3A equals 4 times 2, so I can just multiply down the diagonals. So I get 3A equals 8, therefore A equals 8 over 3. So we have kind of a wacky, we're going to have kind of a wackier looking equation for this. So I'm going to just note here, so my C was equal to 2, my A was equal to 8 over 3. That's a terrible looking 3. Let me clear some space. So now I can figure out what my B is. So I can use that C squared equals A squared minus B squared. And so this is going to be 4 equals 64 over 9 minus B squared. So not the funnest equation for sure. So let's see, if I take 4 minus 64 over 9 equals negative B squared. So if I work that out, I will get that B squared ultimately equals 28 over 9. And that's really what I need to know is B squared, not B. I guess I can just note here my B is equal to the square root of 28. Square root of 28 over the square root of 9, which is 3. But I'm actually just going to note here my B squared is equal to 28 over 9 because that's going to be more helpful with my actual equation writing. Okay, so let me clear some space. Okay, so rounding up all the information that we have now. So I know that this is going to take the form x squared over a squared plus y squared over b squared equals 1. And so now when you fill in this a squared and b squared, so I know it's going to look really weird, but let's just enter it in. So 8 over 3 squared is going to be 64 over 9 plus y squared over 28 over 9 equals 1. So what you're going to do is now you're actually going to take the reciprocal of this so that this doesn't look so jarring. So this actually become 9x squared over 64 plus 9y squared over 28 equals 1. And now that looks much better. And that would be the equation in this case. Okay, and so that brings us to the end of this video. So I will talk to you guys in the next one. Thanks for watching.